Hi, I'm Juliana Galhardo. I'm a PhD student at Unicamp, Brazil, and today I'm presenting part of my thesis. It aims to explore the diversity of Saccharomycotina subphylum, aiming to enhance Saccharomyces cerevisiae performance on corn ethanol production. So let's start here with the introduction. Well, Brazil has a long-term commitment to bioethanol production, and more recently, the process based on corn fermentation has been implemented. So, this process is based on three main steps of preparation of the substrate, starting with the milling, followed by the cooking of the grained grain, and finally getting to the liquefaction. It makes sugars available for the fermentation. Throughout this process, there are many bottlenecks, and the need for robust yeasts, it's the organisms that perform the fermentation, is one of the bottlenecks. So, the goal in this project is to explore the diversity naturally obtained on more distant organisms, such as fungus from Saccharomycotina subphylum. Using comparative genomics, evolutive models, and selection analysis, we aim to identify gene families or mutations that contributed to the phenotype or the capability of consuming maltose. So, getting to the methods, this work has been held with two different data sets. The first one is it comprehends 1,011 genomes of Saccharomyces cerevisiae strains, from which we have access to the microorganisms themselves. And we also have the second data set that comprehends 183 genomes of species from Saccharomycotina subphylum. We use Augustus and Busco, Augustus for gene prediction, Busco for completeness, or to find or to establish gene families, IQ3 for the phylogenetic inference, and HiFi for analysis of selection. But in order to look for the adaptive analysis, it is necessary to identify species within the desired phenotype, which we call foreground. To do so, all 1,011 Saccharomyces cerevisiae isolates are being analyzed over maltose consumption, and a pipeline based on bootstrap tests have been established. So, outgroups considered relevant for Saccharomyces cerevisiae dataset will be used as baits for analysis on Saccharomycotina subphylum. Getting to the results and the discussions, so far we have been able to treat all the data, the genomes from both datasets. Saccharomyces cerevisiae had 99.7% of the sequence assigned to a gene family, yet for Saccharomycotina we had only 96.2%. It is sort of expected since we are dealing with 180 different genomes and species. Our Busco completeness analysis showed that our data are well held. We have low rates of fragmented and missing data. Well, for foreground attribution, it has been done based on the parameters T-lag and Mi maximum. Those parameters are accessed based on the growth on maltose and glucose, which is our control, and the log of their ratio is used on a scattered plot. Using recently strategy, we could identify 20 best maltose consumers over 500 isolates. It's the half of our data set. Further correlations of the strains and where it is prospected shows a great diversity of substrates and applicability of these strains, meaning that probably there is not one major event using the selection event or use that selects maltose consumption. As soon as we conclude the phenotyping, we will be able to begin the selection analysis and then start to properly explore the Saccharomycotina subphylum. Well, I'd like to thank for the funding from CAPS, the support from our program of graduate program, and SEPIA for the illustration. Thank you very much.